Hey, hello, and welcome to today's GFG problem of the day. Hope you are doing well. So let's see today's problem, vertical width of a binary tree. So what the problem is saying is we'll be given a binary tree and we want to find the vertical width of the binary tree. So what is the vertical width of the binary tree? So if you see, so this tree, this particular tree can be divided into some vertical lines. If you see, right? 1, 2, then this is 3. So this 1, 5, 6, they fall into the same line, right? Okay. Then this is 4. This is the fourth vertical line. This is fifth vertical line, and this is sixth vertical line. So this particular binary tree can be divided into 6 vertical lines. So the number of vertical lines is the vertical width of the binary tree. So here the vertical width of the binary tree is 6. Okay, that's what the output is. That's what we want to return. Okay. Now how can we solve this problem? So what we can do, it's easier than you think. Okay. So what we can do is we will take a coordinate. Okay. We will do an in-order traversal of this binary tree. Okay. So we'll take a coordinate, for example, x equal to 0. Okay. We'll start with this root. And whenever we go to the left, okay, to the left child, we will reduce this x minus 1. We'll reduce this x by 1. Okay. And whenever we go to the right child, we will make it x plus 1. Okay, we'll make it x plus 1. That is, we'll increase x by 1. Okay. And also, we are going to take a set. A set. Okay. A set is nothing but unique, right? A unique elements. Okay. So let's start. For example, now, as I said, right, we are going to do the in-order traversal of the tree. Okay. And okay. So we are going to add the element, the coordinate, right? The coordinate, whatever is the coordinate of the node, of the particular node, we are going to add in the set in order fashion. Okay. So let's start. Let's start. So we'll start with x equal to 0. So we have a set over here, let's say. Okay. So we, as you know, in order, what is in order? Left, root, and right. That is, you go to the left child. Okay. Once you process the left child, then process this root. Okay. Whatever operation you want to do, you can do. And then you go to the right child. So this is the order of the in order traversal. Okay. So we'll go as I said, right? We are going to go to the left side. So we'll reduce this -1. We'll make it. Okay. Because x minus 1, right? 0 minus 1, it's -1. It is going to. So there's another left child again here. So we'll reduce this -2. Okay. So -1, -1, -2. Okay. So this 4 does not have any left child. So we are going to return as is, right? We are going to return as is. Now we have processed the left child of the 4, right? We have processed the left child. Now we are going to do the processing of this node. Okay. So we are going to do the processing of this particular node. That is root. Root now in this situation is this 4. Okay. So what we are going to do, whatever is a coordinate now for this 4, right? We are going to ingest in this set. Okay. We ingest -2. Okay. And then we are done here. Okay. Now we have processed the left child of 2, right? Now again, root, we need to process the root, right? Okay. So we need to, so root in this case is 2. Okay. So what we are going to ingest now, whatever is the coordinate of x, whatever is the value, we are going to ingest into set. So we have ingested -1. Okay. Now we have processed the left child of 2, the 2 itself, and we are going to go to the right child. Okay. Now what we are going to do, if we are going to the right child, what did I say? That we are going to add this, whatever is a coordinate with with +1, right? We are going to add 1 to whatever is the coordinate. So -1 plus 1, it becomes 0, right? So the coordinate of 5 is 0. Okay. So now we are going to go to the left, but left 5 does not have left child. Okay, we have processed the left of 5. So now we are going to process this. So whatever is a coordinate for 5, we are going to ingest in the set. So okay, there was no 0, so we are ingesting. Okay, we go to the right child. Right child 5 does not have right child, so we're just going to return. Okay, we're just going to return here. Okay, so we have processed the complete left, right, and itself for 2. Right, we are going to return as is. Okay, we are going to return now. Okay, now we have come to the 1 again. Okay, so now we have processed the left children or the left subtree of 1. Now it's time to process its own, right? This part. You have done this part, now this part. So 0, right? What is the coordinate? 0. It is 0. So 0 is already there anyways in this. Okay. Anyway, so it is going to maintain a unique only 0, as it is a set, right? As it is a set, it is going to maintain unique. Now we are done. We are going to the right child of 1. Okay. So what we are going to do, when we go to the right child, we are going to increment this x by 1. So we have 1 here. So 3, it is 3. So we are going to go to the left child of 3. Okay. In this way, so what you're going to, what it is going to be? So yeah. So let's do it quickly. So when we go to the left child, So here the coordinate was 1. So we are going to reduce by -1. So it is going to be 1 minus 1, 0. The coordinate for 6 will be 0. Okay. So left 6 does not have left child, 0. Now we process this one, 6. 0 is already there. Okay, 0 is already there. Now we go to the right child of 6, right? So 0 plus 1, right? It is going to be 1. Okay. So 8, again, 8, we come here. 8 does not have left child. Now let's process this 8. Okay, 8 has a coordinate of 1. Okay, let's ingest 1 in the set. Okay, 8 does not have right child. So we go back. Okay, again, this we have processed the left and right and itself of 6. Now we're going to go back to 3 again. So we have come here. So 3 has the coordinate 1. Now we'll go to the right side of 3. We have processed the left subtree of 3. So we are going to go, whenever we go right, we add by 1. What was the coordinate? So the coordinate is 2. Okay. So we have 7 here. So the coordinate for 7 is 2. Now we go to left child. 7 does not have left child. So we're done processing left child of 7. Now it's time to process 7 itself. As it is in order, so we're going to ingest whatever is the coordinate of 7. So it is 2. Okay, so it is 2. Okay, so 2 we have, right? So here we have 2, right? Now we are going to go what? To the right child, right? So what we do generally? So what we do? 2 plus 1, right? 2 plus 1. We increment 1 when we go to the right. So we have 3. Okay, so the coordinate of 9 is 3. It does not have left child. Okay, so now we'll process the 3 itself. So we'll add 3 also in this set. Okay, it does not have right child. So we are done processing here. Okay, we'll go back, we'll unwind the stack, and this is our final output. Okay, so whatever is the set size, what is the set size now? We have 6 elements here, -2, -1, 0, 1, 2, 3. So we're going to return 6 in the answer as answer. So this is in this way, we are going to calculate the width, the vertical width of the binary tree. Okay, now I hope you have got the intuition. Now let's go to the code. First, I'll show you the Java code followed by C++. Before going to the code, I'll request you to subscribe to my channel as a lot of effort goes into making this video. Thank you so much. So let me quickly implement the Java code here. Okay, so what I'll do, I'll create a set. Okay, I'll also show the C++ code. Okay, so we'll create a set over here. Okay, and then we'll have a helper function. Okay, we'll pass this root and we'll pass the set and we'll pass coordinate as 0, right? So what is the root here? Root is 1, right? So that is why we are passing coordinate as 0. Okay, so now let me implement the helper function. Void helper, then we have node root, then we have set integer set and x, will say. Okay, so what we'll do now? Okay, so now what we're going to do, let me write the base condition first. If root equal to null, simply return, just don't do anything. Okay, now we are going to go to the left child, right? We are doing this in order traversal, right? So root dot left. Okay, we'll pass the set as is, but when we go to the left child, what we are going to do? We are going to decrement x by 1. Okay, that's what we are doing here. So once the left child is processed, now we'll process the root itself. So what we're going to do? Set dot add root dot data we are going to add. Okay, so whatever, even if the root dot data is 0 here, and if the set contains 0, right? So the set will still maintain the unique elements. Okay, it won't have duplicate elements. So now we'll go to the, once we process the root, we will go to the right child. So we are going to the right child, and along with that, when you go to the right child, what we do? We increment the x by 1. So that's what we are doing here. So let me also return. So what is the set size? Will be our width. Okay, final, as I told you, right? Whatever is the set size. So here is the set size, right? So we are going to return the set size. It contains 6. So that's what is the answer. Okay, let me compile this. Okay. Oh, we got bigger answer. How it is possible? 0 set dot size. As set to check what is the problem here. Sorry, my bad. I don't want to add root dot data. I want to add x, the value of x, right? Whatever is the coordinate. Okay. So let me compile this. Okay. It's compiled successfully. Let me submit. Okay, the test case are accepted. Thanks for watching. I hope you've got the solution. Please subscribe to my channel and like the video. Let's quickly see the C++ code as well. Okay, so here is a C++ code. So we take unordered set over here. Okay, we pass, we create a helper function, we pass set and the zeroth coordinate, and then we check here for the base condition. If it is null, return, right? And we go to the left, we decrement x by 1, then we insert x, and then we go to the right child, right subtree, and increment x by 1. So that's what we do. And finally, we return the set dot size. So this will be the answer. I hope you've got the solution. Thanks for watching. Please subscribe to my channel, like the video. Have a happy, healthy, and a great day. Thank you so much.